We already have a video that reviews the 4 levels of measurement and whether or not data are discrete or continuous. It is a fair question to ask why we're really bothering spending the time to do that. And uh, there are 2 main points that I want to get across. The first one deals with ordinal level data. So if you remember, ordinal level data are data that consist of ordered, like inherently ordered categories. So an easy example here would be 5 data points that can assume one of these values or assumed one of these values. So these are categories. There's no numbers anywhere to be seen, so clearly they are categories, but there is an inherent order. It does not make sense to put this in any other order. We could put high and then medium high and whatever, but the relationship between low and high can't change. They're always going to be on opposite ends. So there's an inherent order of categories, and that makes this an ordinal level data set. We could also have an ordinal level data set that looks like this. So here we do have numbers. In fact, we may even have numbers like a 3.5 and a 4.5, depending. The take-home message number 1, key number 1, is to say that even if your data set consists of numbers, if these numbers are the equivalent of this, so if we could if it is valid to substitute the number 1 with the word low and the number 5 with the word high, then even though these are numbers, or even though they look like numbers, they are actually categories. And because they are categories, we cannot do a lot of our normal math on them. So I've highlighted these values here. Excel will tell us that the average is 3. We could ask Excel to calculate a standard deviation and a variance, and we could do a lot of the statistics that we have been doing on them. However, because, and we would have to know this ahead of time, we'd have to know something about our data. If these numbers are truly categories, then that means it is valid to take this 1, 2, 3, 4, 5 and to substitute it with low, medium, high scale. And as you can see here, because we have words, we do not have an average. We cannot calculate a mean. We cannot calculate any standard deviation. And so, even if our data looks like this, if they are truly categories and not numbers, then even though you can calculate an average, you should not calculate an average. Specifically, you should not calculate a mean. You should not calculate a standard deviation. Some statistics you could still do, so because there's an order, you can calculate a median, for instance, and that's legitimate, and that's probably the best measure of central tendency for ordinal level data. But you should not calculate a mean. So that's message number 1. The other thing I want you to remember from all of this identifying levels deals with interval level data. And so our 2 classic examples of interval level variables is year and temperature. I came up with a different one, and it's going to be elevation. So elevation is something we can measure, and we get a real number from it. So we are in the interval or ratio level range. Elevation, at least in this particular example, the first part, I'm going to say elevation is a number that is measured in regards to meters above sea level. So my 0 point, where I will define 0 to be, is sea level. And so the elevation of my 5 friends' houses, which I made up, I don't have 5 friends, is measured in meters from sea level. So 0, and so friend number 1 is 1,800 meters above 0. Let's say that my house is 3,360 meters above sea level, and I want to somehow compare the elevation of my house to the elevation of friend number 5. I can take the difference of that, and that is my 3,360 minus 1,680. That's just what I've done here. We see that the difference is 1,680 meters. I could take my house and divide by friend number 5, and this will tell me in folds, or a factor, if you will, how much higher my house is, and that's a ratio of 2. So my house is twice as high as my friend's house when we're talking about meters above sea level. Now let's say for whatever reason I want to change my reference level. I want to change my 0 to meters above the Yukon River. And we'd have to specify where in the Yukon River, but let's go with that. So let's say that the Yukon River is 1,200 meters above sea level. So that means I can take my meters above sea level and I want to subtract off 1,200 meters. So now this is just the meters above the Yukon River. So I'm going to do that for everything. I take my friend's house, I subtract off 1,200 meters, and I get a number. Subtract 1,200, and again, and again, and again. And even in my house, I take my meters above sea level, I'm subtracting off 1,200 meters, and there I go. I get some numbers. Now let's ask the same question. How much further in elevation is my house from the same friend's house? Now clearly our houses haven't moved yet. So when we take the difference of this, I take my house elevation minus my friend's house elevation. The difference is the same as it was from my other reference point. Again, my house has not moved, neither has my friend's house. So the real distance has not changed here. However, if I ask for the ratio of my house to my friend's house, instead of my house being twice as high, it now appears that my house is almost 4 times as high as my friend's house. Now this looks very weird and possibly mind-blowing that even though my house hasn't moved and my friend's house hasn't moved, we haven't changed elevations yet, somehow my house is now almost 4 times higher when it was only 2 times higher before. That is the impact of having an interval, or the importance of having an interval level data set. If I'm allowed to move my reference points, then my differences stay the same, but my ratios are not necessarily constant. For most purposes, honestly, this doesn't matter. As a society, especially with scientists and engineers and things like that, we have standards. So the standard of elevation is sea level. So pretty much everyone is going to use this scale, and it is okay to come up with the ratio of 2, because we're all agreeing it's this scale. When we talk about thermometer temperatures, these in Canada, degrees Celsius is okay, and if you want to divide 1 degree Celsius by another, that is also okay. Kelvin might be better, but it's okay. We get into problems when there is not a consistent standard, and the possibility exists to legitimately use a different reference, so to change where your 0 point is. And you end up doing a ratio. So if you were to report a result, you might report a fourfold difference, and it looks really big. And if you were to see that or to report that, you should know that, well, you only got what you did because you chose that particular reference. And if you chose a different reference, you would get a different number. And so it's up to you as a subject matter expert to identify first that it matters what your reference point is, and then to choose whatever reference point makes the most sense for your data and for your analysis and to answer your question. I think for me, those are kind of the 2 really big take-home messages. I will have one more video that just goes through and identifies somewhat quickly the level of data and whether or not it's discrete or continuous. But of all of that, I think if you understand these 2 things, and I'm not saying you'll be tested on it, but going forward, if you understand those concepts, then I'll be happy.